Greetings learners, this is your Sir Brendan and I'm here to discuss the transportation model. So let's start. Major topics to be discussed. What is transportation model in linear programming? And solve a transportation model manually using northwest corner rule, NCR, and Vogels approximation method or VAM. Although there are several techniques used like the stepping stone method, Russell approximation method, MODI or modified distribution method, etc., we will just limit the lesson on the following two techniques for now. What is transportation model? Transportation model or problem involves in determining how to optimally transport goods. Also, it is a special class or type of the linear programming problem, and its specific objective is to determine the amounts shipped from each source to each destination that minimize the total shipping costs while satisfying both the supply limits and the demand requirements. The model assumes that the shipping costs on a given route is directly proportional to the number of units shipped on that route. The mathematical model of the transportation problem. We will now proceed to manually compute a problem using first the northwest corner rule or the NCR and proceeded by using VAM method. This is the problem. The case of Metro Water District in pages 316 to 333. It is an example of unbalanced requirements or with provision of a dummy source because supply is lesser than demand requirements. We will find the minimum transportation costs first using NCR or the northwest corner rule and then the Vogels approximation method afterwards. By the way, as you can see here, the numbers in the boxes represents the cost per unit distributed in tens of millions of dollars. Let's say for source 1, destination 1, the cost in tens of millions of dollars is 16 million. Okay? Another, from source 1 to destination 2, it is also 16 million dollars. In source 1, destination 3, it is 13 million dollars, so on and so forth. In the right side, we can see the supply. It says here that in source 1, the supply is 50. In source 2, the supply is 60. In source 3, the supply is 50. In the destination, the demand for destination 1 is 30. Demand for destination 2 is 20, so on and so forth. Okay? So now we will proceed in the manual calculation. So I have transferred here the data from PowerPoint. So in the first table form, we can see the original value, the original data. The first step to do is to determine whether it is balanced or unbalanced. When we say balance, the total amount, the total in the supply side should be equal to the demand side. Here, if you compute the sum, the total here for the supply is 160 here. For the demand side, if you total this is 210. Meaning, supply is less than demand. What are we going to do is we add a dummy source underneath. So, as you can see, in the second table, no, our initial table, we have a dummy source. And then what are we going to put here? We are going to put here 50. So when we add this, the total is 210. The total for this is 210. So we now have a balance. So the first step is to determine whether it is balanced or unbalanced, and then when it is unbalanced, we are going to balance it by adding a dummy. Okay, so that is the first step. The second step is we are going to compute this using the northwest corner rule. Okay, in the northwest corner rule, we have the following steps. First, start with the root, which is located in the upper left hand corner. When we say upper left hand corner, this is the location, upper left hand of the transportation table. Number 2, allocate the maximum feasible amount to that box or route. So we will begin here, and then we will see the adjacent demand and supply. We can see here that the minimum is 30, so we put the minimum. It means that the demand side is supplied. Okay, we had supplied the demand side, and now we have satisfied the demand side, and for supply there is remaining 20. Okay, step 3, if there is a remaining supply, move one route to the right. So we will move one route by 20, so the total becomes 50. So this becomes satisfied. So we have allocated both the demand and supply. So what are we going to do next? If this is satisfied, move one route downwards. So both are satisfied, so the next step is we move downwards. So since it is satisfied, it is the same, it is 20, so we put an X. So we just put 0 here, so 20 plus 0 is 20. And then next is we go to the right. Now go to the right because this part is satisfied. We go to the right. We will not go to the left, and we will not go down since the demand side is satisfied already. So we will go to the right. So what are we going to put here? We put here 60. So the supply side is satisfied. Okay, so since that is satisfied, the steps repeat again. So we go down, and then what number can we put here to satisfy 70? This is 10, because 60 plus 10 is 70. Okay, so this is satisfied. Then we go to the right. What number can we put here to satisfy 50? Since the demand is 30, we just put here maximum of 30. So this is satisfied. So what are we going to do next? Are we going to go down? No. We are going to go right to satisfy this 50. So what is the remaining value to satisfy 50? So we put here 10, because 10 plus 30 plus 10 is 50. Okay, so there are no place to go but to go down. What number are we going to write here? We will write here 50. Okay, so this ends our northwest corner rule. Then we are going to compute the Z-min, or the minimum transportation cost. So what we are going to do is to just put boxes with values. Okay, this, and this. We just perform some product. So we have 16 times 30 on the first box, and this first box, then plus we have 16 times 20, we have plus 14 times 0, plus 13 times 60, plus 20 times 10, plus 23 times 30, plus m times 10. By the way, m here is a very large number. Now we have m as a very large number. Let's say it is 1,000, 100, or it is 10,000. We don't know. And then lastly, we have 0 times 50. So when we get the sum product of these values, the Z-min is equals to 2,470 plus, we separate the 10m, no? Because 10m comes from here. Okay, so it is in millions, so we multiply this in millions. Okay, so when we the northwest corner rule, this northwest corner rule does not give us the initial or the initial optimal solution. So what we are going to do is to solve this using the Vogels approximation method. By the way, the Vogels approximation method, or VAM, is better than northwest corner rule and any other methods used in the transportation model. So we're going to solve this next using the VAM, or the Vogels approximation method. Okay, the first procedure, coming from the original value, we put a dummy. It is the same example. We put a dummy or an extra row underneath. So we name it 4D, just like the previous problem. The first procedure is we get the difference. We get the difference of the lowest. As you can see in this in the box, there's small box, and we will pick the smallest and the second smallest value, or the second smallest cost. Okay, so in the source one, for the supply side, the difference of the smallest is 13, the second smallest is 16. So 16 minus 13 is 3. Okay, the second row, small is 13, the second smallest is 14. So 14 minus 13 is 1. In here 20, the smallest is 19. We have the tie, and still the rule here, if we have a tie and they are both the smallest, we will consider them. So 19 minus 19 is 0. In here, the last row, the dummy row, we have the smallest is 0, 0. So 0 minus 0 is still 0. Similarly, we will do this the steps in the demand side. Okay, we get the smallest 14, The second smallest is 16. The difference is 2. So for the source 2, smallest is 0. Second smallest is 14. So 14 minus 0 is 14. So source 3, m is considered as a big number, so we will not consider that. The smallest here is 13 minus 13. So both there is a tie. So we have 13 minus 13 is 0. In the fourth, the fourth source, small is 19. Sorry, the smallest is 0. The second smallest is 19. So 19 minus 0 is 19. And here, 15 minus 0, 15. Okay, that is the first step. The second step, we will get the largest among the differences. So the largest among the differences is 19. We will see in this part which boxes among this column is the lowest. The lowest here is 0. So we will take note of this. Next step is to allocate what value that will satisfy the supply or the demand side. So in here we have the smallest is 30, the large, and then next is 50. So we will write here 30 so to satisfy the source 4. Okay, so this is satisfied. We just put an X, and then here we will less 30, so it becomes 20. Okay. Therefore, the next step is to cancel this column. Okay, so we will go to the next table. We can see in this next table that this 4 is cancelled, and then 50 becomes 20. Okay, so you can see that we remove 4 and 50 becomes 20. So we go to the second table. Similar steps. We get the difference of both the sources and the destinations. So the smallest is 16. Oh, sorry, the smallest is 13. Second smallest is 16. 16 minus 13, 3. So 13 and 14, we have 1. 19 and 19, 0. 0 and 0, 0. Here, we have 2. 14 minus 0, 14. 13 and 13, 0. Here, 15 and 0. 15 minus 0, 15. And then we get the largest among the difference. So this side. Then we will get the smallest, which is 0 here. The smallest among the boxes, smallest value, 0. And then we allocate again. So what are we going to allocate? So the least among the two. So the least is 20, so we're going to put 20 here. And this, we will less the 20. It becomes 40. Okay. So therefore, the dummy side will be removed, and the 60 becomes 40. Okay, so we will go to the third table. As you can see, dummy has been removed. and 60 becomes 40. We get the difference. We have 16 and 13, still 3. 14 and 13, 1. 19 and 19, 0. Here, we have 16 and 14, 2. This is still 2. 13 and 13, 0. 17 and 15, 2. Okay, so we get the largest among the differences, and it is 3 here. Okay, and then we will, in this portion, we will get the smallest among the small boxes, smallest amount. So the smallest is 13. So what are we going to allocate between 50 and 70? So the lesser one is 50. So therefore, this becomes satisfied. We will remove this to the next table, and this becomes 20. Okay, we go to the fourth. So meaning the source one is removed, and destination 3 becomes 20. Okay, so that is the next table. We repeat until it has no more tables left and all are allocated. We do the steps again. We have 1, we have 0, this is 5, this is 5, this is 7, and this is m minus 15, because a very big number minus 15. So we will get the largest. So this is the largest. This is a very big number minus 15, and we will get the smaller number between 15 and m. So we get this one. So we will going to put a value here, which is lesser, 60 and 40. 40. Okay. So this therefore is removed or satisfied. This becomes 20. So we will go to the fifth table. So yun na lang po yung natitira. 1, 19 minus 19, 0. This is 5, 5, 7. The largest is 7, and then the smallest among the two boxes, we have only two boxes. This is 13 is the smallest. So what are we going to allocate? Allocate this 20 for both. So this is cancelled. This is also cancelled. So the remaining is source 3. So we will go to the last table, table 6. We have one remaining row. So what are we going to do? We just assign values here. So since this is 30, we will assign 30, so to satisfy this. So since this is 20, we will put this 20 to satisfy this one. Similarly, when we add these two, this is 50. So this is satisfied. Therefore, we are now finished with our allocations. So the last part is we will compute the Z-min, or the minimum transportation cost. So we just put all the values here, no? From our past computations, we will put the values, and then we will perform the sum product. So as we perform the sum product, the final answer that we have got is 2,460. And notice that it is much more lesser than the value of the NCR, or the northwest corner rule. It is the value for the VAM is much lesser, in the form of 2,460. Okay, so that's it. Hope you have learned from my presentation, and goodbye. I will see you on the next video.